is a workplace study on the transfer station in assembly, where the bodies come Rolls-Royce come out of the paint shop and transfer into the assembly department. So I've got a layout here of the process, along with a flow diagram on what the processes are in that area. So basically we start where the body is selected according to the launch sequence on the computer system. We do that via a control panel within the area. So we select the body we need, and it basically calls from an automated racking system the body through on a conveyor. So that's the start of the process. That's called. The next step is where we look out at the layout. We've got the assembly bars are placed onto the body lift hanger. Then the lift hanger is positioned over the conveyor track, ready to receive the body. The body won't come out until that's in the right position, as to avoid any collisions with the hanger and the body coming out on the conveyor. So there's inhibitor sensors that stop the body coming out until that crane is over the right place. So then the body arrives to the transfer station on the automated skid conveyor. The body lift hanger is then dropped over the body, picks the body up, or takes the weight of the body, and then the paint traverse bars, which are bolted on underneath the body, are removed, and then they are lifted and placed into a storage trolley, and then the body is then lifted up and transferred over to the assembly trolley here, which body is then lowered down and put onto this assembly trolley, which is the trolley it remains on until it goes through the whole production line and stuff, parts are assembled to the car. The lift hanger is then disengaged, the body disengaged from the body and then returned to the start position, so it comes from over here back into the start position, ready for the next tact. The paint skid is then sent back to the paint shop via the conveyor using the control panel again. So that goes back into the paint shop and is ready to be loaded with another body. The body protection is fitted to the car when it's in this area. The way it's laid out at the moment, the body protection is quite far away from where it's needed, so there's a little bit of non-value added waste there. The doors are then removed from the body shell and placed onto the door trolleys. So the door trolleys are kept quite close to where they're removed from the car, purely because they're a fairly heavy item and they're manually lifted from the car and placed onto the door assembly trolleys. Then a couple of processes are done actually within that station, fitting blanks to various holes in the body that are tooling holes and things like that that need fitting to make the car watertight, basically. Vehicle identification stickers and build manifest are then printed, so the associate would walk over to the control panel, hit print, it prints all the labels and everything for the car, and the build manifest, which has all the specs and gives people, as the car goes down the line, the options of what are fitted to that car. The manifest is then scanned with a barcode scanner, registering the movement of the car into the assembly department and updates that onto the live electronic tracking system. So everyone else, logistics and everyone else in the business knows where that car is, what department it's in and what stage it's at. And then the body is then pushed manually with the trolley with 2 people round onto the start of the production line, ready for the next tact, and basically the production process starts. And then it starts over again, so that would be 1 tact. So the
Are there any issues with people pushing that?
There is. So there's concern. We have got some concerns for fatigue for the associates, or strains and injuries. There is a process to push it, and they have to follow the process. So, for example, the car has to be pushed by 2 people, not 1 person, but 2 people, 1 person each side, and they have to push it on the A and B pillars, because previous ergonomic studies suggest that that's the best way to push it. It's quite light because the car's not built, so it's on the trolley, and because there's not a lot of weight in the car, it is manageable. But in an ideal situation, it would be suggested to eliminate any sort of manual handling of that. But because of the facilities and the room we've got there, we simply don't have the room to do that. So there are other things in the future state when I come to it, suggestions to make that process a little bit better.
But you said you've got some, you did some data and some measurements around that. Oh, you had some.
So we would have done some. We've done some chalk circles, watching the associates operate within that area.
And some anthropometrical data of people's movements.
Yeah, so looking at their postures, how they handle the. So we do these ergonomic studies that work out how much strain, how much time the associates are carrying out these physical manual handling exercises, and because it's very minimum, we calculate how repetitive it is, and it still falls. It doesn't go into the red as to overstraining or anything like that, because it's done 1 time attacked, and as I say, if there's the right amount of people there doing it, then it isn't so strenuous.
And was it health and safety organisation that recommends 2 people, or how was health and safety executive maybe involved?
Yeah, health and safety. We have planners dedicated to looking at the health and safety and ergonomics, and they calculate. They use systems to calculate frequencies of movements and such things to say whether we're calculated, whether it's in the red or in the green or an amber activity.
Okay.
So looking at the man-machine interfaces, we have the computer input to select and call the correct vehicle through to the conveyor. That's set at a waist height. It's not it's on a desk, and it's quite close to where the operator's working. Then we look at the input to the control panel to move the body lift hanger into position. That's basically the control panel that you use to move the crane to manoeuvre that. The barcode scanner we use to register the vehicle is launched into assembly, and the restricted access round the back of the conveyor. So as one of the safety aspects of that is, if you go in that area, it has a beam that if it's broken by someone walking there, it will stop all the equipment. So the conveyor, the body won't come out on the conveyor if someone's there, which could cause injury if it did.
So is that something like Poka-Yoke or Judoka? The fact that you've got to stop?
Yeah, it's basically a stop, so it's a no-go. So if you go in there, it stops everything dead. So it's like a Poka-Yoke. So there's no way someone could be crushed by the skid coming out because of the sensors on it.
Right.
It will just stop all the equipment and I won't allow it to happen. The same with the lift hanger. Is Poka-Yoke, and unless that's in the exact correct position on the conveyor, the body and the skid won't come out. Purely for this reason, for safety, but also for risk of damage. Because if it's positioned slightly wrong and the skid comes out, it's going to hit the hanger and clash and cause damage to the body. With regards to the layout considerations, it's quite a large, spacious area with enough room to move the body with the mechanical equipment without crashing into anything else. Everything's designed with the floor markings, so everything has its place, and if something's not in the right place, it's obvious because of the floor markings, so it can be quickly put right. Should something, a door trolley or a body protection trolley, be out of place. The tools are stored close to where they're required. So, for example, the tools for undoing the paint bars when the body comes out on the skid are right close by, a waist height, so they can just be picked up. There's no strain or anything for the associate to use, and they're air operated guns for undoing the skids, the paint bars. The logistics gangway route is labelled, and it's labelled to be kept clear at all times, so we don't hold up logistics routes, so parts can be delivered on time. The only issue with the current state at the moment is that part of the process is to use the logistics route to push the car on the trolley round, but it only takes probably about 35 seconds to push that round. So, but for 35 seconds, that gangway, if logistics delivery train was coming around, they'd have to wait. So there's a little bit of waste there that could be improved if we had more space and the layout. If the space wasn't such a restrictor. And there's a good the whole area has quite a good amount of light, both artificial and natural light, so it's a very well lit area. It's important because using mechanical lifters and things like that, you need to have full view of everywhere, so to have a clear and visible environment is really important for safety. Ergonomic features. So, as I spoke about a minute ago, the tools are stored at ergonomic height and close to where they're required. Both the tools for removing paint bars and the tools for removing doors and things like that. The car set parts, so the parts that are delivered from logistics, are kept close to where they're needed on the vehicle. Here, so we don't have to walk so far to get them, so we don't have so much non-value added waste. So if the parts are right where we need to fit them onto the body, then it's quicker and reduces takt times. Before, where they were delivered, they weren't quite utilised, so there was a lot of walking backwards and forwards to the parts trolley, which we identified was, through doing a chalk circle, that it was creating a lot of unnecessarily movement. The the assembly bars, previously to this, they were stored quite far away from where they're required, and they're very heavy bars, and it takes 2 people to lift, and they have to go onto the lift hanger, and these are the adapter bars that basically go into the car body to clamp the car body, and then they position themselves on the assembly trolley. They're now been moved over to here, right by the hanger, where they have to be lifted on. There's still a manual lift, which is again 2 people. Don't know what the exact weight of it is, but it was calculated 2 people are the amount of frequency we only use, put 2 of them on 1 car, so it's 2 lifts per tact. But it's closer and it's a lot better than it was before. The Traverse paint bars, return trolleys, positioned at the front of the track here. The track sits at about waist height, so when you're removing these bars from the car, the underneath of the car, it's a 2-person lift, so each associate would be either side. They'd lift them up. It's at a waist height, so they don't have to bend down, they don't have to overreach, and then they walk them to the front of the skid, and then they're put into the storage trolley. Again, they're quite awkward and quite heavy bars that has to be lifted. So there's definitely room for improvement in that area. And once this paint bar trolley is full, they have to be taken outside to logistics, where the pickup point is, where they get recycled back to the supplier who supply the bodies, which is again another 2-man job with push the trolley round, and it's quite a lot of waste identified through looking at the process. That could be improved. So for the future state, most of the things in this, the wastes, are the ergonomic concerns with everything. So with all the manual lifting elements of the process, the improvements could be made to reduce risk of injury and fatigue to the associates. So some of the things that we could improve would be automated or semi-automated lifters to move the heavy paint bars from underneath the car. We could release them and use an assister if money and space wasn't so tight. We could use that to eliminate the lift, that process for the associate. Also, the same thing with the assembly bars. If we could have an assister that lifts these bars and maybe lifts them straight into the lift, places them into the lift hanger automatically, or with a semi-automatic powered lifter. Would also, you wouldn't have to use 2 people to do that particular job, so it frees 1 person up, reducing time as well, and the need for an extra associate. So one of the processes for fitting the bungs to the car, it can produce quite a bit of fatigue on an associate. So if they've got 20 or so bungs, they have to push in and they do it by hand. They don't have a special tool or anything. It's literally pushing these bungs in over a certain amount of time. We found that they start, their hands ache, and usually it's their thumb. So we've looked at one of the good things we could use is a thumb strap. So
All right. Yeah.
It's like a exoskeleton glove that goes on your thumb, and if we implement this, it will reduce the fatigue on the associate quite a lot. We have actually trialled some in the launch department, and we want to try and implement that for a lot of processes that involve pushing plugs in. Also, another waste that we could reduce is getting the car to the assembly line. Now, if we had some sort of automated conveyor or something similar to take that body, as soon as it's on the trolley, the processes have been done, the car's been scanned, that automatically takes it straight to the beginning of the production line, we'd reduce on time and also labour and risk of injuries through manually pushing that car. So if we could have some sort of conveyor or automated system that takes that car to the beginning of the line, maybe looking at some of the things that we've looked at previously on automated vehicles and things like that for logistics, parts delivery, maybe something similar to that we could look at introducing. And the body protection, so where the body protection is stored, it's because of the layout of the area, we don't have the room to keep it over the side that they're fitted. So another way would maybe have a rack or integrate this body protection trolleys into the tooling rack and have it all in as one in one area, because the body protection, the associates do have to walk. So once they've taken the doors off, the body protection's fitted onto the 2 front wings and 2 rear wings, and they have to walk backwards and forwards to that to fit them. So a better future state would be to have the tool trolley with the body protection all integrated into that as well. So you just have one place to go that's closer to the vehicle where you're operating.
So do you want to just what are those 3? I think there were 3 major improvements that year. Just state those again, restate them.
So for the heavy lifting, so the automated or semi-automated lifters, assist us to lift the paint bars and the assembly bars.
Yeah.
Also the ergonomic thumb strap.
Yeah.
To minimise fatigue on the associates. And a conveyor system or automated vehicle to take the vehicle body to the start of the production line, to minimise the use of the fatigue on the associates around that.
Okay. Yeah.
Okay.
Thank you very much.